Okay, so today we'll start with the superposition theorem. In superposition theorem, where there can be more than one source available. If there is only a single source available, then in that we can't apply superposition theorem. Okay, so the condition is that more than one source must be available. Reason you will know it later on. Second condition is that if there are three sources, okay, we'll solve it in three steps. If there are four sources in the question, then we'll solve it for four steps. Okay, so in the first step we'll take only first source, whether it would be a current source or it would be a voltage source. Okay, so if there is a voltage source must be short circuited because we have to remove another sources, and if there is a current source must be open circuited. Like this you would know it better if we'll do any example. I'm taking one example. This is the simple example. Like tell me how many sources are there in this circuit. There are three sources, right? So we will solve it in three steps. And suppose they had said find current in all branches using superposition theorem. Okay, this is the question. Suppose, so we need to find out the current in all branches. In all branches means suppose this one would be I1, this one would be I2, and this one would be I3. Okay, so what we'll do, we'll take first step is we have to take the first source. As I told you, what is the first source? First, this one is the first source, this one is the second source, and this one is the third source. So in the first step we'll take the first source. This is the voltage source, and this is the second one is the voltage source, right? We have to kill that voltage source. Like we are having one saying na, that ek म्यान में एक ही तलवार रहेगी, if you have listened about it. So in each step there will be presence of only single source. Either it will be a voltage source or either it will be your current source. So in the first step I'll take first source, other sources would be killed out. Okay, so if there is a voltage source, we'll do short circuited for the voltage source. And if there is a current source, we'll do open circuited for the current source. Okay. Like this is suppose 4 ohm, this is 6 ohm, this is 8 ohm, this is 3 ohm. And this was 3 volt. Right. This is 4, this is like suppose 3 ohm. Okay. Clear? So in this I have taken I1 current is flowing. So in this I'll mark I1 dash current is flowing because it is in the same, will take the same direction. This is the main circuit diagram. I have taken here I1 is from left to right. Here also I'll take I1 dash will be from left to right. Okay. I2 will be like I2 dash and I3 will be like I3 dash. Okay, as you can see I have taken the same direction from the main diagram. You can take it opposite also, it like doesn't matter, but we have to make some changes that I'll tell you later on what changes we need to do. Okay, clear this thing? Now we need to calculate I1 dash, okay, and we need to calculate I2 dash, and we need to calculate I3 dash. It's totally up to you. If you want to do KVL, mesh analysis, then you can do that. If you want to do nodal analysis, then you can do that. But according to me, if you are doing superposition theorem, then nodal analysis would be much more easy for you. Okay, so suppose if I want to do nodal analysis, can you tell me how many nodes are there in this circuit diagram? One node, correct. So here is this one node, this is node A suppose. So if we'll apply KCL at node A, if I'll apply KCL at node A, then what would be the value of KCL? That is I1 dash is equal to I2 dash plus I3 dash, right? So now we want to convert it in I1 dash in terms of V by R. Here the potential is VA, and here we have done grounding. So at grounding potential will be 0. So can you tell me what will be the value of I1 dash here if we'll convert it in terms of V by R? This current is moving from which node to which node? I1 dash is moving from 0 to VA, right? So we'll write down what? Tell me. Mm, and we have to take the second sign of the battery. And what is the second sign which is coming in your path? That is plus 3 divided by how much is the resistance which is coming in your path? That is 4. Okay, clear? Now tell me the value for I2 dash. I2 dash is moving from which node to which node? I2 dash I2 dash is moving from VA to 0, so it would be VA minus 0 divided by 6. Okay, next is I3 dash. I3 dash is moving from which node to which node? It is also moving from VA to 0, so we can write down VA minus 0 divided by the resistance. As you can see that there are two resistance in their path, and these two resistance are connected in series, so we can simply add it. So it would be 8 plus 3. 8 plus 3 is how much? 11. Okay, clear? Now what we can do, we can solve this this is a one variable equation, and after solving this we'll get the value of VA, correct? This is only for one variable, we can solve it simply. Where after getting the value of VA, we can put the value of VA here, then we'll get I1 dash, then we'll get I2 dash, and then we'll get I3 dash, right? So what we want in the first step, we need to calculate I1 dash, the I2 dash, and I3 dash that we already calculated. Okay, now in the second step, what we need to do, in the second step we'll take second source. Okay, you will have to write down like this: take second source, kill other sources, right? So see, how can you remember? I told you that if there is a voltage source, you need to be short circuit. Short circuit means like first remove this voltage source, then connect it with a plain wire. Okay, if there is a current source, then in that case you need to be open circuit. Open circuit means you just simply remove the current source, correct? So see, how can you remember this thing like this? Like just imagine this voltage source is your relative. Okay, this is the relative which you don't like, and when you see that your relative is coming into your home, so you shut the door, means you close the door. Okay, and this current source is just like your friend. Okay, and whenever you will see that your friend is coming, what you'll do? Open the door or shut the door? Tell me. In that case, what you'll do? Open the door or shut the door when your friend is coming? Open the door, so that's why I opened the door. Okay, voltage source is your relative, so you shut the door, and current source is your friend, so you open the door. So you can remember it like that. Clear? Now we'll move to the second step. In the second step, what we'll do, we need to take the second source. In this second source is also the voltage source, right? So first source and third source will be removed. I am drawing the diagram again. You have to draw diagram again. I removed the first source. First source was voltage source. Resistance was there. I took the second source, and I killed the another third source also. Okay, what was the value? That is 4, 6, 8, and 12. So I write down this value 4, 6, 8, and 12. Now in the second step, I told you that this is your second step. Here the current flowing is I1 double dash, here the current flowing is I2 double dash, and here the current flowing is I3 double dash. Okay, so now in this case we need to calculate I1 double dash, we need to calculate I2 double dash, and we need to calculate I3 double dash, right? So again we can consider it as a VA node, and this can be grounded. So now tell me, according to KCL, we have to apply KCL at node A. Can you tell me what would be the equation of KCL at node A? Tell me. First tell me, you have to tell me the KCL, that is incoming current. This is, suppose I told you that this is like your college. Okay, so in your college which current is entering? I1 double dash is entering and I2 double dash and I3 double dash are leaving, right? So I1 double dash is 0 minus VA, because this I1 double dash is moving from this node 0 to VA. So 0 minus VA divided by 4 is equal to I2 double dash is VA minus 0, because this is going from college to 0, and we have to take the second sign of the battery. Second sign is minus 12 divided by the resistance, and I3 double dash, again it is going from college to home, so it would be VA minus 0, and what is that resistance value? That is 3. So we can take it again, 8 plus 3 is 11. Okay, so we can simplify this equation, then we'll get the value of VA after simplification, and we can put this value of VA here, then we'll get the value of I1 double dash, I2 double dash and I3 double dash. Okay, fine. Now next step, again in the third step, what we need to do? Now you tell me. The third step, what we'll do? We have to take which source? Third source, right? And other two sources would be killed. Now third step means the third source. First source killed, short circuit. Second source killed, again short circuit. Third step, in this we need to take the third source. Okay, now what is the value? 4 6 8, sorry, there is no resistance, there is 3 and 14. There is no resistance over here, and this one is 3 and this one is 14. Now I mark the same direction, like this one would be I1 triple dash, this one would be I2 triple dash, and this would be I3 triple dash. So by the similar way we can calculate I1 triple dash, I2 triple dash and I3 triple dash. Correct? Okay, now what in the end what we need to do? We don't want I1 dash, I1 double dash and I1 triple dash. We want I1. I1 is how much? I1 dash plus I1 double dash plus I1 triple dash. Okay, so I2 value would be I2 dash plus I2 double dash plus I2 triple dash, and I3 value would be I3 dash plus I3 double dash plus I3 triple dash. So we'll get the final answer. If I change any direction, suppose if I change this particular direction I2 triple dash to the opposite side, then what do I need to do? I will take minus I2 triple dash instead of positive. So I should suggest you that take each and every direction same with the main circuit diagram. Then you have to add positive only. If you change any direction, then in that case you have to take negative for that particular direction. Okay.